Lesson 1, topic exponents. Learning target, I can use the exponent rules to simplify algebraic expressions. First off, our vocab around exponents is the whole thing is called a power, so 3 to the 4th power is, the whole thing is a power. The big number is called the base. You can remind yourself, big number, base, they both start with a B. And then the exponent is the little number. So 3 to the 4th power just means 4 threes being multiplied together. So we have 1, 2, 3, 4 threes multiplied together. So from our investigation that we did last class, if you did the investigation, you learned this. If not, we'll cover it in this video, so no worries. We have product of powers property. So product means you're multiplying. When we multiply two powers, or two things with an exponent together, we can add our exponent. So this really becomes a to the m plus n power. So let's give a real example of this. So we can have 7 to the 2nd power times 7 to the 13th power. And we can simplify that by just adding our two exponents, and it becomes 7 to the 15th power. Now please note that this only works as long as the bases, the big numbers, are the same. Power of a power property, that means we're taking something raised to an exponent and raising it to another exponent. And that's when you can multiply your two powers. So this would become a to the m times n power. So again, let's give a real example of this. So we could have 5 to the 2nd power raised to the 5th power. So to simplify this, we would just multiply the two powers and we would get 5 to the 10th power. And then the last one is quotient of powers property. Quotient means you have division, which will usually be expressed as a fraction. And when we have a quotient with powers, we can subtract our exponents. And we do the top number first minus the bottom number. So again, a real example of this is 4 to the 9th power over 4 to the 6th power. We can subtract our two exponents and it becomes 4 to the 3rd power. Couple more reminders from last class's exploration. We have 0 power. Anything raised to the 0 power is 1. 7 to the 0 power is 1. Now, when we work with negatives, this is when it can be a little bit tricky. If the negative is in the parenthesis, it will come out to a positive 1 for the 0 power. If the negative is outside of the parenthesis, as you can see here, we have negative 9 to the 0 power. This will be negative 1, because this is really the opposite of anything to the 0 power, and the opposite of positive 1 is negative 1. You can also test that in your calculator, and it will also show you the correct answer. Negative powers, flip the power to the denominator. Now remember, denominator is the bottom number of a fraction. So really any whole number is over 1. So this is 7 to the negative 2nd power over 1. So we're really just flipping it, and it becomes 1 over 7 to the 2nd power. 7 to the 2nd power is 7 times 7, which is 49, so 1 over 49. And we did that exploration with our calculator last class. 3 to the negative 3rd is then 1 over 3 to the positive 3rd, which becomes 1 over 27. And again, you can do those in your calculator to test those and remind yourself of that rule. Distributive property. Now this is new. We didn't talk about this last class. It gives the power to all numbers in the parentheses. So you can see we have 2a inside the parentheses, and the exponent 4 is outside the parentheses. So when we simplify this, we give that 4 to both numbers or variables in the parentheses. So the 2 gets to be to the power of 4, and the a gets to be to the power of 4. So it gives it to both. Now when we simplify this, we want to evaluate that number power because we can do that. We can simplify 2 to the 4th power. 2 to the 4th power, if you need to, you can use your calculator. This one will look a little different than yours, but 2 to the 4th power is 16. So we would say 16a to the 4th power. This second example, I would like you to try and then answer an Edpuzzle. So when we start, we give the power to every number or variable in the parentheses. So the 2 goes to the 10, the 2 goes to the x, and the 2 power goes to the y. And then we also want to make sure we simplify that number piece. So 10 squared is 10 times 10, which is 100, x squared, y squared. All right, we just have some practice problems, and then you guys are going to do some practice on your own. So here we have that distributive property again, so we're going to give that power to each number. So we're going to give the squared to the 5, the squared to the x, and the squared to the y. And then again, we have to simplify that number piece. So 5 squared is 25, x squared, y squared. Here we've got a couple things going on. We have multiplication of the 2 parentheses, but then we also have power to a power. So we're going to need to take care of that power to a power first. So we're going to simplify this. So we're going to give that squared to the 5, so 5 squared. We're also going to give the squared to the x squared, so it becomes x squared squared. Now remember, when it's x squared squared, we're raising a power to another power. We can simplify that by multiplication. So 2 times 2 is 4. So this would really be x to the power of 4. 5 squared is 25. And now we get to multiply it by that 2x to the 4th. We're going to multiply these. So when we multiply like things. So the numbers can be multiplied. 2 times 25, we can do that. 2 times 25 is 50. And then we can do x to the 4th times x to the 4th. So remember, when we multiply powers, we can add the exponent. So 4 plus 4 is 8, so that would become x to the 8th power. So it would be 50, x to the 8th power. I would like you to try these last 2, check your answers in Edpuzzle, and then move into your practice.